Every time.
Okay. So here's Mike with a bunch of layouts. Nice! Okay, so we're going to go ahead and average those. Okay, now we're going to measure Mike's radius for the for the layout. 104 centimeters.
Right here we're going to be describing Mike doing a layout backflip. After several trials, we found his average time to be 0.941 seconds.
So the circumference for that circle that I made, like with my feet, you know, we use the same equation, 2 pi r. Our radius, of course, changes because I'm fully extended, and that distance from the center of my mass to the far reaches of my appendages is a meter, 0.4, which is, okay, times pi times 2, which equals 6.53 meters. It's like kind of a weird way of saying that. So finding theta, of course, was the same since it was a full revolution, 360 degrees, divided by 57.3 is, again, 6.53 radians like the other backflip.
The next thing we did was we found the angular velocity, and so we used this equation, omega equals the change in theta over the change in time. We plugged in the information, and the angular velocity is 6.67 radians per second. And the next thing we wanted to find was the angular acceleration. So we used the equation alpha equals the change in omega over the change in time, and plug in that information, and that turns out to be 7.09 radians per second squared.
The next thing we want to do is find the radial acceleration. And our ARAD is velocity squared divided by the radius, which we found back there. And that yields omega squared times r. So our ARAD is omega squared times r. We plug in our numbers, and we get 46.3 meters per second. The next thing we need to find is the tangential acceleration, or ATAN, and we can find that by taking the radius times x, our distance, and ATAN equals our numbers that we have, so we plug those in, and our final is 7.37 meters per second squared.
Find acceleration. So acceleration is the square root of ARAD squared plus ATAN squared. So when you plug in all the numbers, acceleration is found to be 46.9 meters per second squared. After that, you can find speed, and the equation for speed is ARAD equals v squared over r. When you plug in, or you have to solve for v squared, and that gives you 6.94 meters per second.
Okay, now to find the moments of inertia for this layout backflip, we use 1/12 times mass times the length squared, because in layout form, this is the equation that closely resembles me as a long skinny rod, and we find that 1/12 times 77.1 kilograms times 2 times the radius equals 27.8 kilograms per meter squared.
Okay, then finally we're going to find the kinetic energy. For this equation, we use 1/2 mv of centripetal motion squared plus 1/2 of I in centripetal motion times omega squared. We plug this in for 1/2, 77.1 kilograms, times 6.94 meters per second squared plus 1/2 27.8 kilograms per meter squared times 6.67 radians per second squared. And our final answer is 2,475 joules.
It's like 10 seconds.
Here are a few more examples of rotational motion.
Something that you can slide about. Say for instance, my girlfriend, she loves me all the time. But the irony is, she loves me all the time.